Goldberg machine. I'm talking about my part that is abstract and introduction. So in this part we explain the purpose of our project. So after analyzing that as we are students, we are seeing there is a missing and a lack of teaching physics in a dynamic and learning real life situation. So with that purpose we find out to create a machine that's going to stimulate students, their creativity, and is going to increase their understanding about physics concepts such as Newton's force, Newton's law of force, momentum and impulse. And the other part of this project is to create a machine that's accessible to everyone, as for students that wants to learn by themselves, teachers, or even parents that wants to teach at home.
Hi, I'm Abdulhamid. I'm responsible for the proposed design and assembly instructions. The first proposed design had many flaws, such as the fan, which was dangerous, and overall it was very expensive. The second proposed design wasn't very stable, and it was a bit expensive and physically incorrect. The final proposed design was perfect. It was cost efficient, easy to build, and explained physics concepts perfectly. To build the project, you need two tissue boxes, two balls, a large cardboard, and a expandable play tube, and most importantly, four tables and a basket to build it. We made sure that the books supported the cardboard in case it makes any dent, and we used dominoes to stabilize the balls in case they fell over from the table.
This is Nasser, and I'm going to be talking about the learning materials of this Rube Goldberg machine. So I'm going to be talking about the physics laws that were applied. So to start off, as the alarm goes off, it starts off a chain movement and it hits the ball. So this is one of Newton's laws of motion, which says that object 1 applies a force same in magnitude but opposite in direction on object 2, which is the alarm and the ball. As the ball starts moving, it goes down a hill and hits the dominoes. The dominoes, they're standing still, so they have potential energy. Right when they get hit by the ball, this potential energy changes into kinetic energy, and then they keep moving and start a domino effect. This domino effect keeps going and hits another ball. This ball starts rolling down an incline track, an incline surface. This incline surface, the reason why we place it as an incline because the ball, as it's moving down the track, there's a force of friction that might cause it to slow down. But the downward slope, the force of gravity, will overcome that force, and it goes down the tube, and it's downward as well, and then it goes into the basket. Now, we need to calculate the projectile motion, and its velocity, so we know where to place the basket away from the table. So the basket has to be away from the table at a certain distance because the ball is going to go at a certain velocity. We don't want the ball to go over or before the basket. We want it to go exactly in. So that's how we need to calculate all the potentials going into this. So the velocity and the distance, and that's all of it is.
Hello, I'm Buffet. The total cost of our design is $50. The most expensive is alarm clock. We paid it about $15. And the next one is the tube. We paid $12. About the dominoes, we paid $10, and the last one is the small balls. We pay $2 on it. Thank you.
The purpose of this project is to help deliver physics concepts to the kids. The project is very time consuming. As a result, it is very inefficient since a lot of time was spent to explain simple tasks. Although our product is effective, it's nowhere near perfect. But it could be more helpful if it explains more concepts, which increases its effectiveness as well as its efficiency. This project explains concepts that we interact with in our daily lives, and such concepts are overlooked by the human brain and thought to be simple.